All right, this is Unit 5, Types of Reactions. We're going to go over the graphic organizer that I gave to you in class and said to print out and paste into your comp books. Let's start by taking some notes on the 5 different types of reactions that we're going to learn. The first one, and it really isn't any order, I'm just giving 5 of them, so I'm just numbering them for our purposes, is called synthesis. If you look up synthesis or try to watch a video online, they may say the word combination. It is the same reaction. But we, in honors chemistry, are going to use the word synthesis to describe this type of reaction. So identifying traits are just a definition. So when I have 2 or more different atoms or molecules interacting to form a different molecule or compound. I'm just going to shorthand some of these words. Generically, I'll just use letters to generically explain that, to identify it. So if you have some sort of atom or molecule and some sort of atom or molecule, and you've combined them, you've synthesized and made it a new molecule or compound, depending if it's nonmetal or metal and nonmetal. So I'm going to put an example, actual chemical example. You have sodium and sulfur, and when you combine the two, you have sodium and sulfur together. Remember from Unit 4, you have to formulate that ionic compound correctly. So this formula would be sulfur is -2, +1 from sodium, so it would be Na2S. We also learned last week that you must balance the equation, so you must actually finalize that, and the example would look like this. So that's a synthesis. Our second type is a decomposition, which identify it. So one compound breaks down or apart into 2 or more compounds or elements. So it appears to be the exact opposite of our synthesis reaction. If I have a large molecule or compound, it breaks down, decomposes into 2 separate elements or small compounds in an element. I'll give an example chemically. So this CaCO3 would break down calcium oxide and carbon dioxide. Decomposition is one that you will be able to identify and balance. However, my expectation is that unless we're in lab or you're visually seeing this happen, you would have a very difficult time predicting the products of a decomposition. So I will focus on the next single replacement reaction. Please put an asterisk here and put the word activity series. So you need to check, I'll put down, check activity series. And what the activity series is it also was in the Canvas, and I asked you to print it out and place it in your comp books. That is the activity series. Just to give you what that means, it basically is talking about the most reactive metals. Most reactive metals is your lithium. So if you remember correctly, lithium was the one that would react violently in water, versus your most unreactive, your gold, platinum, and silver. And this is why gold, platinum, and silver are used for precious metals to make jewelry. They are not very reactive at all. Along with this, I want you to add to the bottom here of the activity series let's add it to the top, apparently, is where it wants to be added. I'll erase that. So we'll add it right here. Your halogen reactivity. Halogens are the elements right before the noble gases. So they are diatomic, so I'll put some examples of them. bromine, and iodine. So these are the most reactive. So fluorine's the most reactive comparably. So the activity series that I had printed out for you are all metals, while the nonmetals we've just listed right there. And we'll use those in our example. Let's go to the example first. So what is a single replacement reaction? A single replacement reaction is when you have two compounds swap a single, keeps wanting to jump me up here, okay, single element, or even a polyatomic ion. So I'll give an example of what that looks like. If I have a single element and I have a ionic compound or molecule, depending on what this is. So if A is a metal, it's going to swap the metal spot, and then you'll be left with A, C, and then B on its own. However, if A was a nonmetal, it will not take the place most of the time of the metal spot unless it's a hydrogen, but it'll take the place of that nonmetal, and then you'll be left with C on its own and Ba written. Notice that I purposely wrote the products as just products because on paper it does appear like one comes before the other, but in real time when we actually make these reactions happen, they occur simultaneously. But on paper, one of them has to always be written first. It makes no difference as long as the products are on the product side. Let's give an example of this. We have aluminum, and we have, let's say, calcium, or I'm sorry, copper chloride. And then we got to figure out what the products are. We can identify that this is a single replacement because we have one by itself. So let's just call this A. And then we have a combination of something. In this case, we have ionic compound. So we have a metal replacing a metal spot. So this is where I said you need to check your activity series. So we need to check if aluminum is more reactive than copper, then it will actually occur. If it's not, the reaction won't even happen. So this is where we need to check that activity series. We'll look up aluminum. Aluminum is right here. And then if we look up copper, copper is further down. So aluminum is more reactive than copper, and copper would be pushed out and swapped. So in this case, this will actually happen. It will occur. So then copper is by itself. Let me move this down again. Sorry about that. Copper is by itself, and we have aluminum chloride. Aluminum chloride. Notice that I didn't finish the formula. Make sure that you're considering this actual formula. You don't just take the subscript over and write it there. Aluminum is a +3 and chlorine is a -1. So your formula for aluminum chloride is AlCl3. Don't take the subscripts and just write it over. We learned in Unit 4 how to write those properly. We're not quite done because we do need to balance the equation. So I have, let's say I have to put 2 here to make it 6. Chlorine, I'll put a 3 here, which then I'll have 2 aluminum, and then I have to place a 3. And now we're balanced. I think I put an A there instead of a 2. There we go. Typo. There we go. All right, our fourth type of reaction, double replacement reaction. Identifying traits for a double replacement reaction is that they exchange partners. Exchange of the parts of the reactants. I'll give a generic example in my identifying traits. So if I have a large molecule and another large molecule, your A and C just basically swap partners. So I'll have A and D and C and B. Again, it could have been C and B and A and D. It makes no difference. They're just products. Right here, I want you to put an asterisk and check solubility chart. We'll go into the solubility chart on Thursday, Friday lecture. I'll give an example, and we'll take a look and see how we have to predict our product. We'll do lead nitrate plus potassium iodide. You can predict that this is a double replacement reaction because you have two large molecules. So that's double replacement. But how do you actually replace it? Well, your potassium and lead are going to swap places. So you should end up with, let's just do Cb plus Ad to show that it makes no difference. Remember, it doesn't matter what order as long as they're products. So my C is potassium, my B is, there we go. There are no crisscross of charge because they're both positive 1 and negative 1, so we leave it like this. And then we have my plus sign, an iodine from D. We do have a 2 charge for this, so I do need to crisscross that down. So it'll end up this way. We then need to balance. So I have 2 of those, and we balanced our equation. Let's do the last type of reaction, combustion reaction. The identifying traits is that it is some sort of organic molecule, a C and H, sometimes an O as well. You always have oxygen present when something combusts, and you always produce carbon dioxide and water. And when I say always, these are considered complete combustions. And that are the type of the combustion reactions that we are going to actually see in this class. So the example could be CH fluor, it could be any combination of CH, maybe an O as well. These identify it. What I want to make sure and point out is that it really looks similar. So if I was going to write it the way we have before, I would have wrote out that a solo and a combination would have looked like this, which appears to be a single replacement reaction, but it is not. So don't get those two confused because it does look very similar to a single replacement reaction. You want to make sure that you have your entire sheet filled out, and pause and go back and review the samples and examples and the identifying traits, and then we'll go on to the next worksheet, the practice or the homework worksheet to go over the homework.